Okay. All right. Good evening, everybody. Thank you so much for coming out tonight. You went really far. We appreciate everybody tuning in and joining us for this talk that we are really excited to host. I'm Sarah Strew. I'm the Adult Programs Coordinator at VINS, the Vermont Institute of Natural Science. I'm sure many of you are very familiar with VINS. But if you are not, we are a nonprofit organization located in Quechee, Vermont. Our mission is to motivate individuals and their communities to care more about the natural world. And we do our work in three main focus areas with field research, avian rehabilitation, and environmental education. So environmental education takes many forms, and this is one of them. We really appreciate, again, your support of VINS and your interest in these kinds of programs. It's great to be able to host people from all over the place doing all sorts of really fascinating work in different arenas, all centered for caring for the natural world. And a few quick reminders before I get into this evening's introducing this evening's talk. A few Zoom etiquette reminders. We're all very familiar with using this platform, I think, over the last several years, but please keep your microphones muted. Unless you do have a kind of comprehension question, you can put questions in the chat so that you don't forget them, and we will get back to them at the end. And then we will make time for a question and answer session once Brooke has wrapped up. So you can save your questions if you prefer to ask them without typing them into the chat. You are welcome to keep your video on. You can also kind of put up hide your video if you want. We're recording this, so we want as few video distractions as possible. And on that note, I am delighted to introduce Brooke Winslow. She is a dedicated member of the Rozalia Project team for over a decade now. Starting as an intern, she progressed to first mate of the American Promise and is now co-invented the Cora Ball and serves as a field researcher and data analyst for the CSI for the ocean, mapping and monitoring microplastics and microfibers in the oceans. Brooke holds a bachelor's degree in environmental science from Seattle University, and lifelong sailor, and grew up navigating waters of the Pacific Northwest. But now she calls Vermont home, living over in Bethel, and has connections to VINS in a couple different ways, and is joined maybe later by Popcorn, her Newfoundland. Hopefully he keeps his mouth a little quieter during her program, but I am delighted to turn things over to Brooke for tonight's talk.
Well, thank you so much for the introduction. I'm going to share my screen and get started. I've been eagerly waiting to share this with you guys since we started talking about it between me, myself, Sarah, my neighbor Lori, who is also a member of VINS. So we started talking about this last summer. So I'm very, very excited to be here this evening to speak to the VINS community wherever you are, and share my work with Rozalia Project and CSI for the Ocean, which you'll learn all about tonight. All right, let's get started. So we're going to start off with a bit of a game. So kind of settle in, get comfortable, and don't let your keyboard too far away. So we're starting from the bigger stuff of marine debris. We on American Promise for a while had a side scanning sonar. So a sonar using sound to see objects underwater where there's either no light or poor visibility. And there's an object right down towards the bottom of this triangle return of the sonar. What do you guys think that is? What could that be? And Sarah, if you could help me read what's happening in the chat. And I know there's a bit of a delay, so the screen may change after I've done, started discussing what's on there.
Got a guess for a mousetrap, a car, something metal,
Oh,
soda can,
okay,
soda
yes,
bottle.
good guesses. Definitely bigger than a mousetrap, smaller than a car, but it is metal.
We got a cell phone, trash can.
Ooh, a cell phone would be exciting. Trash can, similar, close to size of trash to a trash can. It
Okay, there's a
is
refrigerator.
it is a lobster trap. So it is a derelict lobster trap. This is not a functioning working lobster trap out there in the Gulf of Maine, but one that has been lost and is being overgrown by other sea creatures and algae and all sorts. We do find a lot. So a lot of our work through Rozalia Project is in the Gulf of Maine. So we see a lot of lobster traps, derelict fishing gear, floats, rope. Those are in the top items that we find out there. All right, here's the next item. And again, I know there's a delay, so the screen will change for you in a moment. What do you think this could be? The lighting's greenish just from the water visibility. So the object is not green, but what do you think this could be?
Curtain, jeans, a
Oh,
large trap,
yes, you guys
some
are
sort of.
right on track. So it is fabric, and you are correct. It is a pair of jeans. A very beat up pair of jeans. I don't think you would want to wear them again. Okay, here's one that we picked up off of the sea floor or the marina floor where we were, and the ROV, the underwater robot we were using, we lost grip of it. So it is not naturally floating, suspended in the water column normally. But what do you think this could be?
I guess a red Solo cup.
Yes, that is correct. And
First guess.
um, I didn't know this before, kind of seeing many of them under like in cleanups, but yes, red Solo cups kind of like they break in this weird way of like in strips. So it was just a very interesting thing to learn. Yep, there we go. The American red Solo cup, the party cup. I think we've maybe moved on from these a little bit. All right, getting smaller. Maybe you guys have seen this. I know we find them a lot in along the shores of Lake Champlain, as well as on coastal beaches all around the world. What does anybody recognize what these are? They're maybe half a centimeter wide.
Let's see, we got bottle cap, microplastic beads, pills, bits of plastic.
Yeah, so they are bigger than micro beads, though the beads will come up later. They are what's called resin pellets, or the kind of slang term for them are nurdles. And they are what's called pre-production plastic. So before a manufacturing plant melts or can turn things into like a toothbrush, they have to take these tiny little pellets, melt them down, and then they can become products that we use. So and there's been through the years, there's been spills, there's been a huge amount of loss of these resin pellets all throughout the oceans, just through transport, storms, all sorts of reasons. And so sometimes they're also called mermaid's tears when they're found in the ocean. All right, so now we're getting more towards what you need a microscope to see. This one's kind of on the border, but this is a picture taken through a microscope. What is this? This is the last one.
I'm gonna guess a sequin.
Oh, similar to a sequin.
Yeah.
Quite,
Or a
it is similar. Anybody else?
got a oil, microfiber debris,
It is actually
hexagon,
not,
yes.
it is a piece of plastic that is made to be this small. So it's not broken off of something else, and it is glitter. So this particular piece, I think, came from after a parade. We tape lifted it off of one of our friends' just arm, because you know what they say about glitter. But good news, is such thing as bio glitters. So even if you love glitter, which I can't blame you, some parents might hate you, but there are alternatives to plastic glitter. There are bio versions available, so don't fear. All right, so this, I won't make you guess. This is a clump of microfiber. So the star of our talk tonight is microfiber pollution, and that is coming off of our clothes and our textiles, our rugs, all sorts, anything that has a textile fiber can produce microfiber pollution. And this little tiny piece of a tiny clump of fiber is laid next to a piece of spaghetti. So as a comparison, that is a piece of spaghetti, and you can see how much smaller in diameter all those tangled together fibers are. And when they're on a single fiber on its own, it is considered microscopic. It is very hard to see with your naked eye, and it is all around us, unfortunately, in the air, in the water. And it is coming off of our clothes through all, or at all different stages. It is coming off in our washing machines. It is coming off in our dryers. It is coming off even as we wear and walk around in the world. So this is a situation we're all part of, but that also means we are all can be part of the solution as well. And so I want to first introduce Rozalia Project at a broader scale. And at Rozalia Project, our mission is to clean and protect our oceans and conserve a healthy, thriving marine ecosystem. And we're doing this in a number of ways, led by our fearless founder, Rachael Z. Miller. She's my favorite person. We've been working together for since 2013. Yeah, so almost 12 years now. And she is the founder of Rozalia Project, and she's also a National Geographic Explorer. We will talk more about our partnership with National Geographic and the opportunities it has brought to us all throughout the years, and helping propel our research and our voices about, to share our results and the kind of path towards solutions. So we'll talk more about that later. But first, we'll talk about the ways in which Rozalia Project works. So we do work on marine debris in a variety of ways. So cleanups, but not just cleanups. We're doing data cleanups. We are doing prevention through education. We embrace innovation technology, and we are doing science-based research to understand exactly what's going on so that we can implement solutions. We work surface to seafloor throughout the whole water column. And I apologize if there's a delay here. I'll try. We have an ROV, as you saw earlier in some of the images taken from the ROV, but this is what it looks like when we have are connecting people and communities who maybe live near a lake, near a river, but they are just for the first time seeing underwater, seeing what's underneath their feet, and connecting them to that environment. We call it ROV face, just this unbridled excitement. We love it so much. We work primarily in urban, inland, and coastal waters, and that is because a grand majority of all the marine debris that ends up in the ocean is coming from land-based sources. So we have historically done most of our activities in urban areas or coastal areas, with the exception of some of what we've been doing with CSI for the ocean, of course, in the polar regions. We have amazing partnerships that have allowed us to grow and reach people from all around the world, and continue to be groundbreaking and really pushing for a greater awareness about a lot of these issues at all different levels and different stakeholders. Fundamentally, we are optimistic. So we hope to one day be out of business, to no longer need Rozalia Project. And we think we can make real change and have real solutions to make an impact to protect our ocean and to solve a lot of these problems that we're working to understand and therefore solve. The three main categories of marine debris we work on is derelict fishing gear, like I mentioned earlier, in the Gulf of Maine. That is, we're doing we're working with a coalition of organizations in the Gulf of Maine to do very large cleanups. This is the third. This summer will be the third year of that coalition. We were again working on consumer debris, since that is where a majority of the marine debris is coming from. And then we also obviously work on microplastics, the stuff that is broken off of something else, or in some cases made to be very small, like the microbeads, like the glitter that we discussed before, but also the microfibers fragments. And so when we first learned about microfiber pollution, it was 2013. It was before I was full-time with Rozalia Project, but Rachael and her partner, James, they read about what was microfiber in a popular science article, and they knew that this was going to be one of the biggest problems of our oceans is going to face and our environment was going to face. And so what they set out to do immediately was contribute to the knowledge. And we began doing that through environmental research, field research. We started working on a solution, it is a consumer solution, but it is what we call a human scale solution that anybody who is washing their clothes in a washing machine could be part of. And then also spreading the word. So we knew that this was a problem that hardly anybody knew about at that point. It just hadn't been, there was that one popular science article that they read. There was maybe a couple of peer-reviewed studies, but it really hadn't gotten off the ground in a public knowledge sort of way. So one of our big goals was to spread the word, make sure people knew that what was going on and how we can be part of solutions even now. And we see there are many different paths to solutions. Our activities as a Rozalia Project take place in different parts of this kind of branching model of how we can find solutions. And just at the base of that, we do the field and lab science that will support not only the foundation for understanding the problem, but also the mechanisms of how it's happening, where it's happening, and therefore where can solutions make the most impact. And those solutions take a number of forms. And so some of the solutions that we're most involved with are education, regulation and policy, innovation, redesign, and science communication. Though all of these solutions are very important in the bigger picture as well. And so where we first started our field research was in the Hudson River Valley. And so back in 2016, we did our first full river study. Every 3 miles, we took water samples of the surface of the Hudson River. And then we kind of realized that that wasn't enough. And so we went back a couple of years later to do even more research, where we again took samples from the surface of the water, but we were also sampling we brought an air pump. So we were sampling the air to see what was suspended in the air. We had a Niskin bottle, so we were able to sample the mid-water column and just below, or sorry, just above the river bottom. And we were also collecting soil samples. So we started all the way at the lake tier of the clouds in the Adirondacks, and we threw hiking and whitewater river rafting, and on American Promise, our research vessel, through a combination of means. We sampled every 3 miles to do this very high resolution study. And what we found was fairly interesting to us. So going from Lake Tier of the Clouds, where it is only accessible via hiking, where there are no people who live there, all the way through, there's some agricultural regions of New York, there's forested land, there's, you know, very urban areas in Albany and New York City, obviously. We found no significant, statistically significant difference in the amount of microfiber or microplastics, all what we call anthropogenic microparticles. We did not find a difference between the high altitude regions and to the urban areas. And same thing when we sampled the air. So we had that air sampler that we brought with us. Every time we took a water sample, we are also collecting an air sample. And there again, there is no significant difference. And even with the soil, we did find some correlations between bank types, like the construction, or like the type of banks of the river, to the soil amounts of microfiber, microplastics in the soil. But across the board, there was actually a very little statistical difference. However, what we learned through this process, and through a partnership that we founded with a forensic scientist, this is where the forensics of CSI comes in. What we learned. Something. Okay, so what we had been doing before we met this forensic scientist was we had been looking at what we were filtering out of the water, out of the air, and we were classifying each particle by its color, its material, and its type. And what we realized is that a blue polyester fiber could come from a lot of different things. That calling it a blue polyester fiber was not specific enough to really define where the fibers were coming from, and therefore how could we possibly find a solution if we had such a broad description of the fiber. And through this forensic scientist, she has had, you know, over a decade, multiple decades of history understanding fibers from a forensic or a crime scene perspective. And she brought to our attention is that what they are looking at from a crime scene perspective is they're also looking at the shape of a fiber, the delustrant, which is how shiny or how much, like the plastic fibers are naturally very shiny. So there's an additive on the surface through the manufacturing process that makes it less shiny. And you can see that through a microscope. And therefore it's a good indication of different fibers. You can see that very clearly. And then also measuring the width. And by using these six classifications to describe each fiber that we were finding in our science, we realized that they're in the Hudson River from this 2019 study. There, out of 972 particles, there were 327 different types of particles, whether they were fragments or fibers. And so that is a much more powerful tool to understand that there are 327 possible sources of all this different pollution. And so going from only having three features that we were classifying. Now we can be much more specific. And that has carried through into our launch of our program called CSI for the Ocean, the Global Citizen Science Microplastic Monitoring Project. So we took all that we learned through our multiple studies on the Hudson River, and we have created together with Dr. Claire Gwinnett, a forensic scientist from Staffordshire University, we created a citizen science accessible project that we can do in cities. We're taking it also to the poles, and you can do it with a fairly cost-effective kit of materials that are much more accessible to everyday people than what was previously being done in microfiber science. So we have actually collaborated with National Geographic to share some of these kits with kids in Hawaii. And we are also working with our, so here we go. So yeah, so we took these kits and we were able to distribute them to classrooms in Hawaii where they can learn about their own waterways. There's a student on the Big Island who is doing their senior project on microfiber science in their local area, kind of understanding what is in their own local waterways, identifying patterns, and those in very specific individual categories of fibers to understand their own area. And where our partner, Dr. Gwinnett, she is also working on with another team of people to develop AI and artificial intelligence that is capable of taking a photo of magnified fibers and running it through a machine learning and being able to then identify those 6 categories without necessarily needing a person who is trained on a microscope to go through that whole process. It is cutting out a lot of the time that we need to gather enough information from all different areas around the world to push forward solutions. And this will be a great tool. It is still in development. They're hoping to have a prototype this summer to be able to do testing with more information coming hopefully within the next year of when there could be more beta testing for a public release, so that the CSI for the Ocean program can contribute to the global knowledge database of microfibers and push forward some larger global solutions that are needed as well. And so there's the smartphone app that's coming, but also microscopes are getting smaller and smaller. Depending on if you're affiliated with like a school or something, you may have even seen some of these. They're becoming so much more accessible to have these very high degrees of magnification, even on your cell phone, just as a little simple clip add-on. Clips on over your camera, or like sticks on with like a little sticky material to kind of convert your smartphone into a microscope. It's really, really cool. So we keep our eyes open for new, cheaper microscopes all the time. And so we've been traveling kind of all over the world, which is we are very fortunate to do with National Geographic to do the kind of more academic side of the CSI for the Ocean. We are contributing to the more academic side of microfiber knowledge. And here is one of our team members, Tanya. She's tossing our our trusty bucket off of the ship in the Hawaiian archipelago. We've been to the fjords of Norway, the Shetland Islands, that was last summer, Faroe Islands, again last summer, Iceland. It was about a 3/4 circumnavigation of Iceland. The Arctic Svalbard, where we fell in love with these awesome walruses. We got yelled at by some Arctic terns. And also we did get to see some polar bear butts, which was very, very cool. 2 years ago, I got to go on the trip to the Falkland Islands, which was really, really cool because we saw some fantastic birds from the flying type to the swimming type of these rockhoppers, as well as albatross. We got to see a bunch of albatross colonies, as well as the penguin colonies. And I knew I had to include these because the Vins folk are your bird lovers. Mess that up. Hold on just a second. Apologize. I made this special for you guys. So I made a little error there. Okay, here we go. All right, so it's South Georgia. So we got to go from Falkland Islands to South Georgia. And we saw there's these amazing elephant seals. This one's a skua. I remember that one's name. There were fur seals. And then of course we saw king penguin colonies that are like the things of documentaries and Google like Planet Earth is these documentaries where you see, bays, massive bays just packed full of these amazing penguins that are, there's like the year-olds of babies that are covered in their downy feathers. There's the molting adults. It was really magical to see that. And then we got from the South Georgia, we went to the South Orkney Islands, which was a little bit of a surprise due to the conditions. We got to go there. Here's the bird there is locally called a pintado, and it was scavenging from a leopard seal kill that happened while we were cruising around in the Zodiacs. And that this particular bay had to be hundreds of thousands, quite literally hundreds of thousands of chinstrap penguins, like nesting around the cliff sides. And we also saw my very favorite. These are Adelie penguins. And this colony became my absolute favorite because we watched this particular guy stealing rocks from the other penguins' nests for his own. It was like the funniest thing because they're all screaming at each other, protecting their little nests, and then they just go around stealing each other's rocks. It was very, very cute. And yes, Adelies are now my favorite. And then finally, we went all the way down south to the Antarctic Peninsula. And this is from just a couple months ago, where Rachael returned for the second time and so I was not with them on this particular trip. But my year, we did see the holy grail of all penguins, the emperor penguin. We were very, very fortunate to see them, the first one from afar on the ship. But the next morning, we were even more lucky to hang out on the sea ice. So this was like how everybody, if you wanted to see how everybody felt about this sighting, was everybody had their giant cameras out, taking as many pictures as they can. And we were so lucky that they just kind of hung out for over an hour while we just admired them. And how could you not? These guys are just so special. And there were people with us on the ship who have been researchers and been going to the Antarctic Peninsula for 6 years or more, and this was their first time seeing emperor penguins. So it was such a special experience to get to see those guys. And of course, there's also the larger marine mammals in the water. Unfortunately, I do not have a camera the size of my arm, so these are photographs taken through a pair of binoculars with my cell phone. So not the greatest quality, but we love them all the same. There's a particular pod of species of Southern Ocean orca that is, I don't think it's quite yet designated as its own species, but it is close to being, it's recognized that way, as well as we saw a few different humpback whales through our travels. All right, so after all the beautiful photos, we should remember why we were there. And that was to sample for microplastics from the air and the water at each of the stops along the itinerary. And we did indeed find microplastics and microfibers from every single one of our expeditions. And so we have to remember that we were looking at these to categorize them by those 6 characteristics. And based on those 6 characteristics, we are finding and comparing across all of our different expeditions, we found some interesting results. And so if you think about, so I'm sat here at my desk, and if I were to rub on my sleeve, some fibers might come off of my sleeve and land on my desk or in my tea, who knows? But if you were to take a sample of what fell off or what just landed onto my desk, you would probably find a large number of fibers from my sweater, and then maybe a few from the other articles of clothes in my house from days ago. And so if you think about it that way, we consider, like, me rubbing on my arm would be a mechanism of loss. And so if you think about how many fibers of my sweater you would find on my desk, you would find a lot more here than you would on the windowsill, 5 feet from me. You'd find more of those fibers on my desk than 5 feet away. And so we kind of translate that understanding to what we're calling a ratio between the categories and the number of particles in that category. And the lower than that number is, the closer your sample is to where the mechanism of loss took place. And the farther away, the higher that number is, the farther away from that mechanism of loss you are. And so our results follow that idea, and so that the samples from Long Island Sound, the ones that we've collected in Hawaii from the Nautilus ship, and the ones in the Hudson River are on the left side of this graph, closer to where those mechanisms of loss are, closer to the populations, quite frankly, and where those fibers and microparticles came from, as opposed to the Southern Ocean or Arctic Svalbard, or the green bars of this graph, and they are much farther away. So consistent with our expectations. And now this map shows just the one expedition going up to Svalbard, and then we started up in Svalbard and then finished along the northern coast of Norway. And on this expedition, we were at first a little bit surprised to see that the places where we found the most microfiber, the 2 hotspots here on this map in orange, they were not along the Norwegian coast, but they were far, far north, where there is no one living. There's maybe there's like a town far to the south, but there's no one at all living there. So we're like, okay, well, let's think about why this could be. And so another naturalist on board with us said, like, oh, I have an idea. And they showed us this map. And hopefully you'll see this animation. Okay, great. Thank you, Sarah. And this shows that the path that the ocean currents take from leading from the northern Atlantic. So even before that, the Gulf Stream coming up the eastern seaboard of the United States. It crosses the North Atlantic, and there's a branch of that North Atlantic current that goes up towards Norway. It goes past the Norwegian coast through a lot of fishing grounds, and it dead ends right up in Svalbard. It's circled at the end there. And so these types of results that we're consistently seeing throughout our expeditions brings us back to how are we going to protect these places that have precious creatures who are far away from where this pollution is coming from in the first place. And so we believe that in order to protect these guys, we've got to, number one, take care of what we own, take care of what we have here that is possibly contributing to our environmental pollution of microfiber pollution at a grand scale, even on a local scale, and then more diffused the farther away you get. But it does start, here where we are, wherever you are. I know we have people from all over the country, which is fantastic. So we can all be part of this solution to protect those precious creatures in faraway places by starting with, our own homes. And we knew that kind of start right out of the gate. We knew we wanted to be part of the solution, like ourselves. And so I mentioned earlier that we had developed a solution, the Coral Ball. So I want to share a little bit more details about it. This here is the Coral Ball. It is made here in Vermont, and it is preventing microfiber pollution in the first place in our washing machines. It is helping protect our clothing. It is helping protect our environment. The design was inspired by coral, because coral is able to capture tiny bits of tiny bits of food from flowing water. And what we needed to do in our washing machine was capture tiny bits of particles also in flowing water. And so it is very, very simple to use for anybody with any washing machine, whether you have one in your own home or if you go to a laundromat, it can come along with you. And here's a little video of a tiny little clump of fuzz, and hopefully the bandwidth holds strong so you're able to see this, and then so you can see a tiny bit of fuzz that was pulled out of the Coral Ball is actually dozens if not hundreds of pieces of microfiber. And so by capturing it or preventing it in the first place in our own laundry, that is going to be a very big part of preventing microfiber pollution. And we have had a great amount of success and support from people who also understand that starting with the 30% of microfiber prevention that the Coral Ball can have in your washing machine is going to make a huge impact for our environments. That everything that we can do to prevent microfiber shedding from not just using a Coral Ball, but also washing in cold water, spot clean, wash less, only when you need it. That sort of thing is also going to be a huge part of the solution in the end. So other examples of ways we can be part of solution as individuals: slow fashion down, don't buy it unless you really need it, or if you know you need to buy something, buy good, better quality or secondhand. Those tend to shed less over time and cause less harm. from not just individuals. There's certainly lots of opportunity for industry to take ownership and to make very large sweeping changes that could have a much larger positive impact. So supporting textile innovation, we need our clothes to not be coming apart. We want the fibers to be stronger. We need the materials themselves to be less harmful once they get out into the world. And also this can also be driven by policy as well. So there's in California, there have been proposals for washing machines to be required to have filters that could address microfiber pollution. So that is one way that we can use policy to push the industry to make changes as well. And I will talk about a local success story of policy, not for microfiber pollution, but certainly for microplastic pollution. So we'll get to that as well. So I want to use this last section of the presentation to kind of talk about solutions that are working in other areas that can kind of give you some inspiration to think about where solutions for microfiber pollution can come from by taking inspiration from these other working solutions. So through Rozalia Project, I mentioned before, we're going beyond cleanups. We are doing data cleanups. And so that looks like we have our data card on the Marine Debris Tracker app. So if you do your own cleanups in your neighborhoods, at a local river, or if you go to a beach, you're welcome to download the Marine Debris Tracker app and contribute what you've collected to the overall body of knowledge to understand. Because as you learn patterns, you can start to address local solutions. And so let's play a little game to work on your observation skills, give you a little test. All right, so pull up your chat, and I want you to look at this image, and each vial here in this photo is small and microplastics that have been collected from a different beach from around the world. So 5 different beaches are from all around the world. What do you recognize anything in here? Is anything jumping out at you that you recognize?
Someone said sea glass. I think I see some of the foam from like pool noodles.
Oh,
thread,
yeah.
straw, plastic netting, fish netting, foam rubber, fishing line, and straws.
Oh, there's things that look like straws. Those are not actually straws. I'll tell you, I'll reveal what they are. But does anybody know what these straws are? Or what the straw like like the plastic sticks? Yeah, those are all good things. All right, so what looks like a straw or a plastic stick. What I originally thought was like a stick from like a sucker or like a lollipop. Like that's what I originally thought those were. But it turns out in many countries around the world, the Q-tip swabs have plastic sticks. And there is a breakdown in waste management communication. And so a lot of cultures will flush those Q-tip swabs down the toilet. And they end up in the waterways on the beaches. And there are so many of them. It's pretty crazy that there was this disconnect, kind of lack of connection between what goes down their drains and what ends up in the ocean. And so there has been some communities an effort to do some messaging campaigns, also giving out trash bins for bathrooms specifically to encourage people to not be flushing things down the drain. In these photos, you will also notice there are resin pellets, and I think just about every single one of these vials, they have resin pellets, that pre-production plastic. There's absolutely some fishing netting. There's absolutely some bottle cap material. And so last question for this slide. One of these is from Hawaii. Which one do you think is from Hawaii? And why? If you'd like to share, let's see. 1, 2, 3, or 4, 5. Put the number in the chat. I don't believe there's a tampon applicator in here. I don't think we would have picked that one up for this.
Oh, we got it. Guess for 4, for 2. Another for 2.
4, 2. I was able to pull up the chat finally. Figured it out. I can see it now. Okay, so a bit of a spread of guesses. Okay, so the answer, come on, there we go, is number 2. So what is distinctive about number 2 to me is that most of this stuff in this vial is very sun bleached. It is very pale in comparison to some of the more vibrant colors like the purple and the number 4 from Fish Hook, Cape Town. Definitely the Alicante, Spain one. You guys, I don't think anybody guessed that one. You were correct. That was not the right answer. And that pale kind of sun bleached factor indicates that these particles were probably floating around the ocean for months and months and months in the North Pacific Gyre, because the Hawaii is kind of right on the edge of that. And so they were out there in the environment for a long time before they got washed up on the beach. So that's part of what the process that we go through as when we do beach cleanups. Oh, there's the resin pellets. There's the various sticks in there. Very common to find. And so we do a very similar thing when we do cleanups with either kids or adults. So it doesn't matter who we're doing this with, but we are once after we've cleaned up a beach or a waterfront somewhere, we will sort what we find and collect the data. And then we ask the kids, what stands out to you? What do you see here that's crazy? They're like, how could this possibly be? You know, start asking questions of how it got here. Why is it here? How could it? And then we start, after we ask those questions, we're like, okay, well, let's start thinking about solutions. And solutions, as we said before, can come in all different varieties. And we have some great games that we play to talk about behavior change. How do you convince someone to change their behavior in their own personal lives? We talk about innovation, product innovation, either creating something that never existed before to solve a problem, or taking a product that has a problem in its design and changing that to prevent the problem in the first place. This was a particular group of students who were part of a summer camp, a marine science summer camp, and there was half of them were from China and half of them were from Ghana, and they had very, very different experiences with just like the cultural expectation of how to deal with their waste, and how the government should step in and enact policy or provide infrastructure. And so they were able to have a fantastic exchange of cultural information to work on the solution to whatever their project, their item of choice was. I don't remember exactly which one they chose, but they were having a very interesting conversation based on their cultural backgrounds. And of course, we were able to share our experiences developing Corobol. You know, it was not a linear path. Like, you don't go from problem, first idea to production. You have so many iterations of ideas and revolutions of new thoughts that can kind of change your direction. Like when we realized that we wanted to emulate coral and what coral was doing, it really changed our direction. And so we were able to share those experiences with the students and to kind of inspire them of like, oh, this is, you know, inventing something, you know, if I have a whole new novel idea, there's something there that is valuable, and that, you know, if you pursue it, it could become a true solution. And so more examples of different types of solutions that have been working out there in the world for various problems of marine debris. Someone mentioned microbead earlier today, and Beat the Microbead was a campaign that was very, very successful. So if you remember that there were plastic microbeads intentionally put into facial exfoliants, toothpaste, all sorts of cosmetic products, that once we've realized exactly what was going on and how they were going straight down our drains and into our environments, that there was a very effective campaign that has successfully banned microbeads in many countries all around the world, and cosmetic companies effectively, you know, you have no reason to make them anymore because there's so few markets that will allow them. So that was a very, very successful campaign. Another messaging campaign is Balloons Blow. I don't know if you've heard this one. This is a great one, especially around birthday parties, graduations, celebrations. There are different ways of celebrating that don't need to involve balloons. So we love this campaign. I think more people need to know about it. Art as a form of messaging is also really powerful and important. So here is an example of an installation on a beach in Busan, Korea. There's a very lovely artist who we've worked with before. She came on board American Promise one summer to gather materials for her beautiful sculptures that use all marine debris. And they are a powerful tool for communicating a story of where this stuff comes from, the harm it can do in our oceans, and we need to protect our oceans and the creatures who live there. We worked with a sustainable fashion designer a couple of years ago to make this beautiful rope dress out of derelict fishing gear, and did a fun photo shoot all around for American Promise. And another category of solutions is innovation and redesign. So looking specifically at materials, what are things made out of, and what can we do better? I love this slogan, "Design to disappear" is like the best slogan possible. And really considering the end of life for products is something that we love to talk about. And these straws, I believe, are made from like a kelp material that will biodegrade after use. There's a movement to create materials for our textiles that is what we call bio-derived and bio-benign. So it is bio-based, therefore it is not made with fossil fuels, extractive materials, and then it will also on the back end be bio-benign. So even though our fabrics may still be vulnerable to breaking up, and little bits of fiber coming off, whatever does come off, if that is not harmful, it is bio-benign in the environment, then that would be a very big improvement. Oh, something that we learned about last year was that there are hundreds of thousands of microplastics coming off of our plastic cutting boards. If you use a plastic cutting board, I don't think you should. that's one thing you shouldn't do, is every time you're using that cutting board, plastic is coming off into your food. We searched around for a wood cutting board that was one piece of wood made without wood glues or wax, varnishes, waxes, oils, anything. We couldn't find one, so we ended up making our own. And it's the core board. We have a partner in Middlebury who we make these together with. It's Vermont maple, made here locally. One piece of wood, and that's it. And we love them. And thinking about places where waste management is very, very difficult, there are communities who have taken their waste and made it into a building material. So thinking about how can we take waste that we don't know what to do with and do something novel and new and productive with as well. There are solutions in US cities, such as Mr. Trash Wheel, to clean up the rivers, to keep the trash that ends up in the river from storm events, to keep it from flowing downriver. They have this trash wheel that diverts it and can pull it out to keep their waterways cleaner. There are chemical recycling efforts that are being researched to take waste products and turn them back into their original molecular compounds. And that can be a way for us to no longer to either reduce or stop the extraction of oil for the use of plastic products, to kind of close that circle and keep that material closed loop. There's some great movements for sustainable eating and kind of making things more local, kind of lowering footprint at a local scale to kind of keep within your own local area for foods. I think Vermont has a great number of initiatives to make that happen. We have so many fantastic farmers markets year round. And so that's also, it will be a part of keeping our footprint, like from packaging, from carbon, transportation costs, keeping all of that under control. There's policy. So there's policies for plastic bag bans or plastic bag taxes at the grocery store. We have one in effect here in Vermont. There's a great number of recommendations for policies that could really make great changes from the waste management standpoint to prevent this stuff from ever escaping out into our environments. And here's a great success story that I really wanted to share with you guys. So there's a thing called unencapsulated polystyrene foam flotation. And this has been a known problem for a long time. These specific ones, one was on the breakwater of Lake Champlain, and then there's docks from the Connecticut River. And here is collected from the sediments, from a settlement sample on the shores of Lake Champlain. The docks are breaking up very, very quickly. They are exposed foam. They can get damaged in storms. They can get washed up on shore. And from there, they just break down so quickly, and it's so difficult to clean up. Here is another one. This was the second dock explosion, as we call them, that we cleaned up that one particular summer. That kind of really showed us how much this needed to be addressed quickly. And so in the last couple of years, we've taken our data collected from our cleanups, and have been advocating together with the Conservation Law Foundation for a ban on these unencapsulated foam docks. And it passed. success. So we together we were actually we were very happy to be successful. And last year it was this bill was passed to ban the use and the sale of these unencapsulated foam docks on Lake Champlain in Vermont. So we do need New York and Canada to get on board as well. But this is a huge step forward and a huge local win for policy to show that, you know, that the use of data can drive these policy decisions, because without that data, you know, people aren't going to necessarily listen, or you know, you can have as many anecdotes as you want, but they need to, you know, sometimes it comes down to seeing those numbers. And so that's what we're doing here. Okay, so open up your chats again, and we're going to go through a little thought experiment about what kind of solutions do you think would work for preventing microfiber pollution. So I'm going to open up my chat so I can see what you guys say. So here's some suggestions, and I want you to get your responses. So yes, no, maybe, need more information. Just let me know what your gut feeling is on these, and we'll go through a list. So labeling laws. Do you think there needs to be information on how much a garment sheds? Like as you learn about a garment in store, online, should there be information about how much it sheds? A lot of yeses. People don't read labels. That could be true. Yes. I think so too. I think it could be very useful. I think there does need to be some guardrails. So for example, oh, good job, Susie. You read labels. Very good. So guardrails for this to be, so for a company to not just be able to say whatever they want, kind of a thing. So maybe if there was a standardized way of measuring how much a garment sheds, and then that is the standard by which all of these labels are written, or kind of the scale is designed, I think that would be very interesting. Okay, next one. We'll go to the next. Should there be coating/treatments on textiles to prevent shedding? What do you think? Need more information? Yeah. Not if they're chemically toxic. Depends on the material. Yes, as long as non-toxic. Not more chemically based treatments. Yeah, so that's a good yeah, what's the coating made out of? That is the big question. So there could be, you know, you're trying to prevent one problem of the shedding, but is there another unintended consequence of, you know, you're not going to prevent all the shedding. So what is that substance that you're putting on the garment, on the textile? Do we think it's going to cause more harm down the road? So yes, so I think we do need more information. That needs to be top of mind for anyone developing a coating or a treatment, that it, you know, once it ends up in the environment, what is going to happen then? Will it prevent that garment from being recyclable on the back end of it once the whole total garment have seen its end of life? So there's a lot of questions around that one. Oh, there's a good question here I can answer. So is there a problem with natural textiles? So Chris, good question. And we do address in our research, we acknowledge all natural textiles as still be, well, not, so if we are able to identify that they have been dyed, we still include them in our results as an anthropogenic microfiber. So it is still a man-made microfiber, and because even if it's a natural cotton or a wool, those fibers can still be treated with dyes, optical brighteners, wrinkle releasers. There's all sorts of pretty gnarly chemicals that go into making our clothes that we still, those are still on natural fibers in a lot of cases. There are some fully organic down to the dyes textiles available. So if you find something like that, that's amazing. But unfortunately, they're not easy to come by. And especially for us in Vermont, when you're experiencing -5 degrees, overnight, sometimes you do need something a little more technical to keep warm and to be safe. So, sometimes the natural fibers, either they're not accessible to everybody or it's just not feasible at the moment. So good question. Okay, so next option is making textiles out of biobenign, biodegradable materials. So we just talked about this. Yes. Yes, I think wherever we can, this is a great thing for sure. And if we can get those, the same technical performance that we get out, that we expect in like our puff jackets from a new biodegradable, biobenign material, that's, what we really want material scientists to be working on to develop, so that we can, get out there and not worry about it. Okay, next question or next possibility. Telling people to stop wearing synthetic garments. Do you think putting some sort of stop to that is a good idea? Good luck. Suggesting, maybe. Yeah, I'm on the same wavelength as you, that we can certainly educating everybody about what's going on with our with our garments, with our textiles, so that everybody can make an educated decision. I think that is absolutely what we should, where we should start. And then we want those biobenign, biodegradable materials that have the same performance as what we expect in our synthetic garments. That's a better, what's this question? Affordability will be an issue. Yes. Yeah, so there's also there's a lot of like wool options that could possibly provide the same performance. However, often cases they are more expensive. So yeah, so we can't necessarily tell people to stop wearing synthetic garments. So an idea is that companies should stop producing so many synthetic garments. I think that demand needs to kind of come from the consumers. Like it will be very difficult for to tell a big corporation that needs to happen. But I think we do have a lot of say by what we're doing with where we're making our purchases, what kind of standards we have for when we are going to purchase something new, or if we're tell them like, hey, I'm not going to buy that because it's not the quality that I expect or I need. I think that can possibly move those companies eventually. Okay, next one. Regulation on emissions from washing machines. So a lot of shedding is happening in our washing machines. The Coraball can prevent some of it, but it's not, but we do need, yeah, I would say absolutely. We do need filtration on washing machines. Yeah, I agree. And so, yes. And so then I think we can start this kind of push towards policy. That I think that right now it needs to come from local and state conversations, because I agree national politics are kind of fraught at the moment, but we can still have these conversations because there are still people who care, and that can still happen. Okay. regulation on emissions from dryers. So I didn't talk about this as much, but there is even for all of our electric clothes dryers that are vented to outside of our homes, there are fibers that are being spewed out of our homes because our lint traps are not catching they're not catching 100%. So there is still quite a lot of fiber that is being blown out of our homes. So wherever you can hang dry, please do. It's better for your clothes in the long run anyway. Though we understand that's not possible all the time. And your towels could get scratchy in some cases. So not always feasible. Yeah.
There was a
Oh.
question in the chat earlier, and I think it just popped up again about how to, responsibly dispose of dryer lint, and then also if you're
Yeah,
using a
so
Cora ball, how to dispose of that.
yeah, good question. So the dryer lint or any of your laundry lint, it is a mixed material. So it is natural fibers, it is synthetic fibers, could be your hair, your dog's hair. So that mixed material right now cannot be effectively recycled. And so right now, unfortunately, it should just go in the trash. At the moment, we are hoping that that we know there are some people working on ways of recycling that material, possibly mixing it into concrete, doing something with it so that it's not just going to landfill. But right now there isn't a effective recycle or other route for it to go besides just the trash at the moment. Okay, next one. So in-drum devices and aftermarket filters. Should these be required? Because both exist. So Core Ball is an example of an in-drum device, and then there are aftermarket filters that can be put onto your plumbing. Marge, I don't believe so. At least in the US, cities are not dumping their waste into the oceans. Most of it is either going to landfill. There are some states where they have waste to energy where they burn their waste. But at least in the US, I believe that practice has been prevented, come to a halt. All right, so next, most people said yes, and I agree. Well, until there is some washing machine level prevention, then yes, I think we should advocate for the in-drum device and aftermarket filters. All right, consumer behavior change. How much do you think it should be on the consumers to make behavior changes? I got one yes. Anybody else? Needs a lot of education. I agree. Consumer needs to be part of the solution. I agree. Education. Yes, I think it's yes and no for me. I think consumers we should educate. We should share all the ways we can protect our clothes that also protect the ocean. We should educate people on which low shed clothing is best suited for outdoor activities.
We might have just lost Brooke for a moment. We'll get her back on though. Thanks for hanging in there, everybody. We will try and get Brooke back on. Her computer battery might have just died on her, so I'm sure she's trying to plug in and get back in here. But in the meantime, great conversations going on in the chat. And remember, I have been trying to keep track of questions that were asked earlier, and I made a few notes, but if you do have questions that you would like to ask Brooke, and maybe don't necessarily want to unmute and ask them yourself, feel free to pop those in the chat and I will make sure that we get them to Brooke when she gets back on. One question that I know I can answer right now. Thanks, Susan, asking about coral balls. We do not currently sell them in our nature store at Vin's, but I think certainly looking at a variety of the different products that they sell, the coral board and there you are.
I'm back. Oh, I'm so sorry. My internet just like completely went out for a second.
Yeah,
oh,
no,
so
that's
sorry.
fine. But yeah, thank you, Susan, for the suggestion. And we definitely, it's something that we will be looking into at the nature store.
Yes.
I was trying to do my best to answer questions in the meantime,
Thank you,
Brooke, but
Sarah.
I
Thanks for
could.
holding on the fort. I apologize, everybody. I am back. We were close to the end anyway. So yeah, no, if we want to go through questions, I'd be happy to see if we missed any questions or if anybody wants to unmute and ask their question.
Yeah, there was one about kind of a maybe more of a rural question, or for people who live more rurally, about septic systems. And you know, in Vermont, at least, most of us are on, a lot of us are on septics versus town water. Can you talk a little bit about microfibers in septics?
Totally. Yes, absolutely. So this still matters to people on septic systems. So once your wastewater goes into the septic system, there's some of the solids kind of stay there, kind of get biodigested, but also the plastics will also stay in there. But then also some could make their way out into your leach fields. And there have been a few anecdotal cases. I don't know how prevalent this is, but I do know there have been cases where people's leach fields stop working properly. And when they dig them up to fix them, there's all sorts of crud and like nasty stuff, like including plastics in there. So we definitely want to don't flush anything, that you don't want getting in there. And also when your septic system gets pumped out, every year or every few years, that sludge goes to a wastewater treatment plant that then, it's part of the process. Fair amount of those plastics get stuck in the sludge, depending on where your stuff ends up. Sludge sometimes gets landfilled, sometimes gets burned, sometimes gets spread onto fields, for, like agricultural fields for fertilizer. So either way, we want to keep as much out of there as we can.
And then someone had a specific question about dental floss. And wondering if that was appearing a lot in your samples, and kind of what issues there are with.
We have not recognized specifically dental floss. That's an interesting one. Though I know a lot of dental floss is either made out of plastic or coated in wax. So it would be fairly persistent in their environment, but we haven't identified that specifically. So good, but interesting to keep an eye out for.
Well, I guess it's a question about recommendations that you have for detergent sheets or other earth-friendly products that you can use kind of alongside coral balls in your washing process.
Yeah, thank you for that question. We've gone through a few different options. So we at first we really were a fan of the detergent sheets. We've learned a little bit more about them. So and now we're more on the fence about detergent sheets. So they're fantastic for from the viewpoint of like footprint, like transportation footprint, because they're just like a dry sheet. And so there's like no water weight that you're shipping around. They're much easier they're not sticky to deal with. But we have learned as that the same material that's around like the detergent pods, that kind of plastic, like what seems like a plastic material, it is a synthetic material, and that same stuff is being used to hold the detergent sheets together. And that material dissolves into water, but it is not it's a little bit light on the research to know how it behaves once it gets out into the environment. Is it fully being if it's being eaten by a sea creature, what's happening there? So we're more on the fence for detergent sheets. I don't mean this to be necessarily a plug for you to buy anything from us, but we have vetted the Blue Land. The company makes a tablet detergent that's like a dry detergent that's just like made into tablets. We sell those, we use them, I use them myself, and I like them, but and they don't have the PVA, which is that material that's that kind of gluey material that keeps the detergent sheets together. So check those out, see if that's something that you want to try, but again, not necessarily a plug to buy it from us.
And then from earlier on, kind of using the Cora ball, there was a question about how to clean it, and then also, what is it actually made of?
So got one right here. Here's one right here. So the Cora ball. Well, first of all, they asked the question about cleaning it. So the Cora ball, you don't need to clean every wash. Just you'll kind of learn how quickly it captures stuff in your own laundry. It is preventing more than it is catching. So if you'll, I mentioned that earlier that I hope I mentioned it earlier that the independent testing has shown that it is preventing between 26 and 31% of microfibers from our clothes coming off in the first place. And we think that's just because it is helping reduce the amount of friction of your clothes up against each other in your washing machine, which causes a lot of shedding. And so the amount that is being captured will depend a lot on like the type of washing machine you have. The top loaders produce a lot more microfiber than front loaders. It depends on the type of clothing you have. It depends on how long your hair is. If there's hair in there, it tends to aggregate fiber more faster. To clean it, you just kind of see like little clumps of fiber in there. You pull the little arms apart, you pinch it out, and you throw it away with your dryer lint as well. The material of the Cora ball. So you mentioned it's made in the US, and the material, it is a synthetic rubber, so it is a plastic, but we have chosen a material that is very, very durable. Like mine I've had for 7 years plus, still going strong. And we designed it with repairing it in mind. So if there's like one part that breaks, we're able to send you a new part rather than replacing the whole thing. That was important to us because we want to keep as much out of the landfills as we can. And then on the back end, once you are ready to get rid of your Cora ball for a new one, we have a take back program. So we take them back, we disassemble them, we clean the parts, and then we are able to turn them back into new Cora balls. So we do that all here in Vermont.
And there's a question about, is cold water washing better than warm water, specifically for microfibers, microplastics?
Yes. So cold water washing causes less shedding. And so, yes, I would recommend unless you have like, a wash that's like super soiled and needs a real deep clean, for everyday washing, I would recommend using your cold water or tap cold, depending on the season. You know how that goes. But yeah, using cold water with a cold water detergent, make sure it's a cold water detergent. Yeah, I would recommend that for sure. Okay, so I will put, so coraball.com is where you can go to buy any of those things. And then I'll put in the chat, Rozalia Project.org. And so if you want to read more about our results of CSI for the ocean, we have links to each of the, they're called story maps, where you have fantastic maps and photos and the results from each of our expeditions. I recommend, if you're interested, go check that out. You can find the links at rozaliaproject.org.
And there was any recommendations or pro tips on washing with the Cora ball?
Yes, I see that. Avoid using straps. Yeah, so I don't separate anything out when I use my Cora ball, but there have been cases where people's, undergarments might get tangled up a little bit. Usually that's not a problem, that doesn't cause damage, but if you're concerned, and I totally understand, yeah, wash things with spaghetti straps, the lace, fine fabrics, tassel. Don't wash it with anything with tassels. It loves to suck in those tassels and it becomes a little project to untangle it. So yeah, so there are a few items that we recommend washing separately or putting those items in a garment bag if you've got one.
I think that's just about everything. Oh, someone was asking about the Alliance to End Plastic Waste.org. If you've heard of that or familiar with that.
I've heard of it. I'm not personally familiar with it, but I think they've got a good information that, if it resonates with you, go for it. I think they've, there's a lot of organizations that are doing great work, kind of in parallel, working towards the same goals. So. Well,
sorry if I've missed any others. If you asked a question earlier and you still want to get that answer and I missed you, I apologize. Throw it in the chat now or unmute. But otherwise, I want to again thank everybody for coming out tonight and joining us in this. And Brooke, thank you so much for sharing your time with us this evening and all of the amazing work that you were doing with Rozalia Project and Cora Ball. And sounds like you have a few orders coming your way potentially.
Well, thank you. Thank you, Sarah. Thank you, Lori. I see you in the chat. You've been very supportive, cheering us on. So, and it's fantastic to finally work with you guys. And I hope we get to do something in person at some point, because that'd be a lot of fun. We've got a lot of fun activities to continue getting hands-on and learning about microfiber. So yes, so yeah, I would love to do something.
So everybody stay tuned. More to come.
Yeah, for sure. All right. Thank you, everybody. Have a great evening.